Hi, Artem. Thanks so much for joining me today.
Hey, thanks for having me.
There are things that we learn in our childhood which help us and contribute to our success in lots of ways, both career and personal life. And there are things we have to unlearn from our childhood. What are some things you learned from your childhood which have helped you? What are some things you've had to unlearn?
Totally. So, it's a super interesting question. I think as a kid, there was a lot of, uh, as a first child, there's a lot of the need to uh, find and be independent and find solutions to problems because no one else is going to be there to help you out to do those problems, to solve those problems. And I'd say that was the thing that I had to do early on, and it's something that continued on into a lot of the work that I do now. One thing that I did have to unlearn is the fear of public speaking. So growing up, I never liked to take the stage. Even speaking in front of a class was always a difficult thing. It gets so nervous to do that, and nowadays it's still kind of you get kind of get the jitters, but you there's psychological tricks that I've learned that help me be a better public speaker and not worry so much when I'm on the stage, for example. And so that's been one thing that I've had to unlearn. But I'd say everything else has been kind of like I'd say say you're the nature and the nurture arguments. I do think that there's an aspect of once you're the environment that you're born in and kind of can help mold you into the next stage of your life.
And maybe extrapolate that environment into AI. And as we get into AI learning new things, how much of, and maybe this question doesn't completely apply for AI, but how much of AI learning do you think is nature versus nurture? Was something inherent in AI and its capabilities versus something it's learning from its environment?
Oh, you brought up a super interesting point. So the interesting part is uh, AI right now is very much in the non-physical domain for the most part, meaning that it's all on your screen. You can't physically touch it yet. You could, I mean, what, self-driving cars and Waymos and some Tesla robots, they're kind of learning from their environments. But the concept is that majority of AI tools are SaaS tools, and those tools are primarily in a non-physical, tangible world. And so a lot of the models that are used to kind of interact with the world, they're evolving with the premise that um, someone's coding them. So that's kind of the nature component, right? You're kind of ingraining in their coding certain lines of code on how action items and scenarios. The more interesting part will be when AI is more interacting with the physical world, and that's where it starts to learn new things. And it's not there yet, but I feel like that is the next frontier with robotics, for example. Robotics right now primarily they're programmed to do specific sets of tasks. So I went to I got a smoothie the other day, just because the thing that was making it was one of those robots that kind of just it had a bunch of fruit and it just was self-programmed to pick up the fruit and then to put it into a blender and then mix it and then pour it into a cup and push that cup out. But it was pre-programmed with a specific set of instructions. Now it would have been a different experience if instead of there was just a touch screen, I selected what I wanted and then it just output for me a drink. Imagine it was a humanoid robot standing there and I would have a conversation with it. What would that be like? That's kind of where like the future state of if this is going to be a future reality like that, then imagine having the AI continually learn by interacting not only with humans, but also with other AI robots, for example, or other AI systems. What is that going to look like? I don't know, but I think it's an interesting next shift in technology development that we're in right now, that we're observing. A lot of it's moving pretty quickly, but it's still more or less, not everything, but more or less constrained to the computer for now.
So currently you're an AI fellow at Stanford. Tell me more about kind of your day-to-day work there, and then walk me through the trajectory of your career. And you can start as early as high school. And what does your career look like so far?
Yeah, my career is pretty non-linear. I grew up wanting to be a doctor, and instead of going to medical school, I ended up going to graduate school. So kind of still became a doctor, but not that type of doctor, the other doctor. I always get sometimes get asked the question. I'm like, "Oh, can you prescribe me something?" I'm like, "No, I can't. Unfortunately, I'm not that type of doctor." So things were very nonlinear, and actually, I'm very happy that I chose the PhD route rather than the MD route. There's a lot of, I feel like opportunities that have been ones that I've been able to kind of tap into because of having the more um, research heavy experience that you get through a PhD allows for you to kind of see a lot of different components. So I studied engineering computer science. Through that, we developed smart devices for wound care, and then seeing clinical translation from the research to a bedside application was super interesting. But then also, how do you integrate AI safely in patient data and going through and mining the data for useful corollaries to predict wound healing? What sensor should I put into a device that would output a successful result, meaning that a wound is getting better, and here are the sensors that are changing. Here's what I need to, and here's how I need to modulate the treatment parameters, etc. And then in doing that, it was quite interesting to see how AI is being deployed in the clinical space, and then how AI development or AI research is happening on the research side with patient-related data. I was interested in that, and that I transitioned into more on a fellowship role after graduating to extrapolate more of these risks that are tied into AI development. And so that's where a lot of the work now has been thinking about, if you are to deploy AI systems, uh, what is reasonable? How do we ensure that we are mitigating bias within the algorithms? How do we make sure that patients are safe and that we want to not have unforeseen risks or problems for vulnerable patient populations? And how do we like equitable deployment of AI tooling and a lot of these different topics we get to kind of think about more on the from the ethics lens, and then thinking about how do we work with policymakers to translate that into more policy efforts that can help people not only understand the limitations and the possibilities of AI systems, but also, okay, if we were to create policies, how do we not hinder innovation, but also make sure that we are uh, um, uh, modulating risk such that um, it's not propagating and just kind of doing whatever. And we're considering patient safety and so forth. So that's kind of how my research work informed me in terms of the AI work at Stanford.
I have two different questions. The first one is this is something I find in academics and physicians quite a bit. Is they value their product and the technical problem they're solving and the technical solution they're developed, I would say 80 to 90%, and the value distribution the other 10 to 20%. And there's a graveyard of excellent solutions which would have done a lot of good in the world and saved a lot of lives that didn't make it to market and did not commercialize because of not valuing the latter. What are kind of your thoughts here? And to kind of build on this, as a physician, wound healing, a lot of it is just clinical, right? I look at it, a wound, I'm like, is it healing? There's certain things I look at, but it's very subjective. There's no you can get into pressure and vac wounds and the specific pressure in the wound and if it's alive or if there's dead tissue and measuring it. But to be frank, in most of the clinical community, we just look at it and we just say it's necrotic or it's not necrotic. Is it warm? Is it cold? But it's very subjective. And then asking me to use a solution to replicate that usually requires tons of data and FDA approval. So I guess it's a two-part question. One is how do you think about distribution? And then what do you think drives clinical adoption for medical devices and technologies such as these?
The hardest part is, I think what you're alluding to there is changing a physician's mind in how to do their job, right? And because there's a certain aspect of kind of like, yeah, if I were to make a parallel with sports athletes, um, they got to a certain place in where they are in their career by doing things a certain way, and it's been working, and things have been going well. So why would a sports athlete change their diet if they made it to the NFL by eating burgers and nachos, for example, and telling them that you can't eat that anymore because now you have to do something better? I was like, well, don't tell me what to do. I've gotten here because I've been doing what I've been doing and it works really well for me. Clearly, I'm performing on the field. Similarly, with physicians, often there's an aspect of I've seen a lot of cases, I've treated a lot of cases, I know how this is done. Why would I adopt a new solution that is not within my workflow or is going to disrupt my flow, standard of care, etc. And I think what's super important there is to tie in and having physician partnership and buy-in earlier on. So if you're developing solutions, there's a component of working with the physicians to actually develop something that's useful because there are problems that are still not solved in the medical domain that physicians don't have the time to solve, but they'd love for someone to go solve that problem. And so that's the biggest part is if I were to partner with you, for example, and create something, what would be actually useful for you that you'd be like, yeah, that would help me do my job better rather than that is not a useful tool for me to use and I'm not interested in that tool. So that's where I think the difference is between things that are more adopted within the community versus not. And even if you can get more physician buy-in by, say, having a co-founder as a physician, if you're developing a med tool, or if you have some folks on the board, those folks at least can advocate for you or advocate on the behalf of what you're developing. So on our smart bandage technology, we were fortunate that it was being led by Dr. Jeffrey Gertner, who is a physician scientist. He sees patients. He was at the wound care center frequently. He was treating wounds, so he saw the problems that were happening in that space, and he was keen on having solutions that actually can be put on patients' lives and create things that would actually be useful. And so for him, it was a very clear ROI investing the research time into it in terms of having some sort of product that can then be eventually shipped onto patients. But then again, that is because of his interest in it. If he didn't have an interest in it, it would be a different story.
You've kind of touched both the academic world, but also the finance and the VC world. Tell me about how you got into your gig as an entrepreneur in residence, and then maybe tell me a bit about your work with OpenAI.
Yeah, so the beautiful part about Silicon Valley is that there are so many opportunities for you to just show up and participate in. And I mean that in a in a way of one of my mentors, Ron John Nag, he at one point said, there's ideas laying on the ground. You just got to pick one up and go with it, kind of thing. Like there's plenty of things to do. It's just a matter of execution. That's the first thing. He's like, another part is just show up. You don't know who's going to be in the room. You don't know who's there. You don't know what you can do if you're not there and you're not present. And so there's this if you've seen now this more push of people going back into the office or returning back into work and so forth. And there's a certain aspect of convenience of being working from home and being able to do a lot of the work from home. And I feel like there's a good balance between work from home versus work in the office. But there's a certain value add where if you're doing problem solving or critical problems that you need to identify solutions for, to be in a group setting where you can work there together with folks. And so um, with kind of the entrepreneurial side, there was a lot of when I was doing my PhD program, um, people are doing startups all the time at Stanford. There's uh, the graduate school business. There's a ton of startups coming out from there. There's the uh, biodesign folks. There's a lot of other entrepreneurship hubs on campus and so forth. So I was quite keen on understanding what that ecosystem was like, particularly from a science perspective, where we as a scientist bring technical expertise to the table. However, and that we don't necessarily know the non-technical stuff. And how do we learn the non-technical in order to talk to people about the technical, but also have a frame of reference for, like earlier, talking about the valley of death and translating technologies. How do we, if you weren't exposed to that value, you didn't know what that existed, you would have one perspective on it. So it's the flip side of the coin that I think is super valuable that you get from an ecosystem. And at Stanford, you get that as an ecosystem, and so that's where I was able to plug in and kind of participate and learn from that ecosystem, and then learn and bring the domain expertise of computer science and engineering, biology, all wound healing, all that to the table when evaluating a company and looking at a company deal, and then taking that as reference point and understanding how the market dynamics respect and review that situation. So that's kind of how I got involved on the investment side, because there was a certain aspect of technical domain expertise that I was able to bring to the table that someone, say, who's only getting an MBA does not have. Because there's a component of, just like when you're doing a PhD program, you go deep into a topic and you're the world's expert in a specific topic. So you're going to be able to talk about that topic. I can talk about wound healing and stuff that works and doesn't work. I've been out to all those conferences, all those trade shows. There's a lot of stuff that doesn't work. There's a lot of people trying solutions, but they're all within the same scope, right? Everyone's trying a better dressing, a better hydrogel, a better skin substitute. There's all the stuff that people are trying, but is it moving the needle forward? Is that going to really push the needle on innovation forward? Or is this just another thing that isn't really going to do anything, and you're just not going to have a product market fit and so forth? So that's kind of how I got involved with that, and it's been a fun journey to be able to be on both the investment side as well as the operation side, and kind of straddle both and see two sides of the coin synergistically.
We're seeing this with AI scribes, and even though they don't technically as work as well as the standard of care, they're worse than the standard of care. They're receiving immense market adoption because they make things easier for me. Do you think there's a parallel here to be drawn in medical device where maybe something doesn't even work as well as the current standard of care, but it just makes my job easier? And or do you think success, and by success I mean an exit for a startup, is more contingent on the product working or their ability to sell into clinical workflows and yeah.
You need to do both. So in order for them to sell into the clinical workflow, I hope the product has some sort of workable something or another. So in your example of scribes, you're right that they're not fully there, but at least they get you 80% or 90% of the way there, and you can quickly correct it, which makes it faster for you and actually makes it better for the patient, because then you have all the quick transcription notes, and you can kind of make sure that the patients have enough documented history such that you have a more representative view of what you and the patients talked about. Um, for medical devices, you would have a certain need to have the device work well, I hope, because in order for it to get approved, you would need to document and prove that the device actually works. Uh, the what I've noticed on the adoption side, it goes back to one, is someone going to pay for something that you're developing? So in the medical device space, it's quite difficult because you need to find someone who's willing to buy what you're building. And if you don't have someone who's willing to buy what you're building, don't build it to begin with, is kind of the motto that I have now adopted, because you can spend all this money, investor money, your money, to build something, and then you have no interesting party to say, here's some money for it. And then you're stuck because you've developed something, you think the hospitals are going to buy it. Hospitals are actually not going to buy it. And then what? And then you're kind of stuck with just holding the bag of your device that you just developed. So there's this true component around, if you're going to build something in the medical device space, if it's something that you're planning on implementing with patients, it needs to be, if it's something that needs to be prescribed by a physician, you want that to work well. If it's something that people can just buy at your Walgreens or your CVS as kind of their own option, that's really up to them. They can go and buy something as a device or some sort of feature, like say, I don't know, a a specific type of walking instrument, for example. Or right now, I've seen ads where there's the exoskeletons that help people walk upstairs and so forth. And they're lighter, faster, better. And you can kind of buy them for only $799 or something like that for the basic one. But if you want the faster battery pack, it's 1,200 or something. Like there's a whole gamut of things, but those are, I feel like, the ones that are consumer oriented. So it's a consumer market play rather than specifically a hospital play. And so it really depends on what the entrepreneur is building and what they want to deploy through the market fit. But anyone who's building a startup needs to have some sort of product market fit idea earlier on. And then, especially if you're going into something that is going to be more business development heavy, you should start those relationships early, as the general just now.
What are your thoughts on digital therapeutics as a category? After what happened with Pear Health, we're kind of seeing the category not take off as much. And it seems like we have this inherent, um, you know, inherent feel that I can take a pill to make something better. But if it's a digital solution, it's less likely to work. And it's not really grounded on fact or any logic. It's just the way I think we as a market or as humans feel. What are your thoughts on digital therapeutics? Do you kind of see them? Um, are you bullish on them? Are you bearish on them?
Depending what domain they're in, I think right now we're in a space where digital anything is easily disrupted. And it's a question of if you are to invest in a company that has a digital angle of digital therapeutics, for example, a mental health app, for example. If I were to invest specifically in that category, does that bring a return to the fund? That is kind of like a big question here. Um, I don't know if it does right now at this moment on May 30th, 2025. It could be something different tomorrow. It might have been something different yesterday. I bring this up because it is a very disruptible space and a consumer play is very hard, especially in digital. You're trying to get people to use your app versus another app. Attention spans are difficult to capture. People are busy, people are distracted with everything. Trying to have them get yet another app is quite hard. And right now, there's something called vibe coding, where you can just build your own app if you want. So then the higher order question, now I'm literally asking if someone's pitching a idea of like an app, I ask and I say, can I vibe code this up myself? Because if the answer is yes, then you have no business. It kind of, I hate to say it, but if I can take your app, recreate it for 199 in 30 minutes and launch it by using a few services to kind of launch it onto a web app store or something, what is the business model for people who are developing digital health apps? It comes down to, have you captured a market segment and consumers willing to buy into your service specifically? That's your moat. It's the data that the people are allowing you to capture and the people that you've pulled in and said, please stay, and they want to stay and use your service. Otherwise, you have no digital moat. Everyone else can now pull that up. I think I even heard a talk from or a mention that the LinkedIn founder said that he vibe coded up LinkedIn in 30 minutes. The same website that they spent many, like many dollars and a lot of time on, one person, 30 minutes. He's like, crazy. You can do literally the same thing by just using some of these new tools that are being developed. So then that for all the founders listening, rethinking that strategy. Like, what is your moat? That is the most important part. And specifically in digital, how fast are you getting it into people's hands and are they staying? are these people staying with you versus going somewhere else?
How far are we from a point where a person like me who has no coding knowledge, I can maybe say hello world and that's about it. How far are we from me being able to vibe code a solution um, for a mental health app, say,
You can
which
do it today.
has that?
You can do
Okay,
it today. You
so
can go
that
on
being
something called lovable.dev. That's like one example. And you can use language and you can chat in that site and say, I want to create a mental health app with these features measuring these markers. And it's going to go and think for about 10 to 15 minutes and it's going to output you an app. And then you can kind of say, oh, I don't like this feature. Can you please modify this? Or can you change this? And et cetera, et cetera. And you modify as you like. But you can do it now. There's tools
and
out there that
it will debug the back end as well.
it's do yes. And so if something's not working, it'll like, for example, if you're trying to push something that's not working, it says error, you tell the app, you tell Lovable, like, there's an error. I'm confused. It's not allowing me to do it. And it will say things like running a script to identify errors, fixing the errors. It looks like we identified errors and we fixed them and stuff. So you'll get workable something. And then if you were to deploy that, then there's a few other steps you take in terms of QCing and making sure that it's on a specific server and stuff. And so those few things say you can use chat to identify what are the steps for you to launch an app and what vibe code tools exist for you to go from a prototype version to a full deployable version. But you don't necessarily need to write your own code. You can do it now if you want.
So for an AI solution, does defensibility now lie solely in the distribution advantage, or is there some inherent product defensibility?
That's the hard part right now. Everyone's trying to figure that out. Like, what is the defensibility of AI solutions in which if I can vibe code it out, what happens to how do you IP AI? And it's quite hard, right? That's a very hard problem to that people are solving right now. But I go back to if you're developing any kind of AI solution, your moat is your people, or your business or your clients, whoever you're saying are going to use that. That's your moat because if you have a solution which you have hundreds of thousands of people on and they like it and they continue coming back to it, then you have a growth strategy in which you can pull in more people. If you don't have that and they can churn and go to another place, doesn't matter how great your app is, someone else can develop that. If they can pull your customers away from you and customers don't come back, doesn't matter.
That being said, what are your thoughts on the future of knowledge work? Are we all marketers in the future?
I think we're all creatives in the future because in order for you to get a good output from AI tools, you need to have a good way to prompt the tool to do the work. And prompting comes from having good understanding of the English language in this case, because a lot of the tools are being built out primarily in English, but there are other languages coming online. Being able to ask the AI the right way comes from being able to communicate in English the right way in order for the tool to understand you. So you going back to being more creative thinkers and creatively walking through a task is something that more people are going to get used to. I don't buy the AI will replace people because that's been an argument that's been said over the last 100 years. And we're still around and there's still money to be made and there's still different types of jobs. There's new types of jobs that come out every single time there's one of these pushes, right? Even an influencer. I didn't when I was growing up, there was no such job as I can be an influencer. Now that's a whole category and a huge market, right? Um, how does work change? That's the whole interest. That's no one really knows because technology is moving so quickly. But if you've noticed, kind of some AI tools are going really fast, but then there's some companies that are like, it's not working as well, so we're scaling back in the amount of deploying AI that we're having. We're going to have more humans in the loop. Why is it that it's not working well? Well, it's because the solution is hallucinating. There's an aspect that the solution was not trained on a certain set of data. It wants to provide you with an output. And so it provides you with what it thinks is a reasonable output given the structure of the data. But it's not the correct output because of what you know as correct by format. So then the higher order question is, how do we rectify this, right? How do we balance that? And it's still going to be, there's a lot of human in the loop component that is still going like, that still needs to happen. And so I'm not at the point that AI is going to replace us at this point yet. I feel like it's AI will only enable us in terms of doing even more interesting, fun stuff.
This is a full circle moment where the most competitive and the most useful degrees of the future might be arts and language degrees and
Yeah,
not STEM degrees,
yeah.
which is a
People,
very, very interesting reality.
I think people need to understand how computers work, how AI systems work, how architecture stuff works, how large language model works. But I don't necessarily believe that you it would that you will not be able to get some interesting application layer on top of that. I think that we don't necessarily know what jobs might be created because it's moving so quickly and it's uncertain what work will look like. Clearly, work is being augmented and certain laborious tasks are being offset with tooling that's being developed, but it's still in its early phases of being iterated on and tested. And so the higher order question is, what is that equilibrium once we reach a certain adoption, a certain level of adoption? What is that equilibrium and what does that look like? And I feel like that's still not decided yet.
Do you kind of buy into the Sequoia philosophy that the future unicorns and decacorns will be application layers built on these platform companies versus should we still be building new models, new platform companies for AI?
I've heard of that discussion around kind of Web 1.0, Web 2.0, the Facebooks and the Googles, and those are all built off of the internet. And so this is similarly, AI tools are one set of or AI language models. Models themselves are your application, your foundation level, and then the applications are built on top of that. I don't think any of us have seen strong, convincing applications that have come out just yet because they're all sort of integrated. Even, for example, Google's recent announcements with VO and a few others, the things that they come at, pushed out, not only like killed a bunch of stuff, literally, but in a way, a lot of startups were working in certain verticals specific to creating video and creating images and such. And then you have Google Showcase in which they're dropping video models, image models. And so how does that redefine the application layer companies that are working in that space to specifically be really good at specifically video creation, for example? Uh, we don't necessarily know yet what the next Facebook will be in kind of looking at the landscape, but there's still a lot more work to be done in model development to make them be similar to human thought, human reasoning that a lot of people are still working through. So it's still pretty early stages. A lot of the exciting work happening right now in the AI space is focusing on reasoning, focusing on um, the decision making, focusing on modeling psychology in AI systems. And that in itself is still fairly new. And that's where social science comes in and having people who are studying social science partner with computer scientists to develop more human-like models is super exciting, in my opinion.
So one of the key things I think, and I'm not technical, is the internet has no owner because the military kind of standardized the TCP or the ICP, and from what I understand, those are like how to design an internet protocols. Um, Anyone can then go ahead and build like the internet isn't one internet; it's multiple autonomous networks. We're not seeing this in the AI foundation models. People own these models. There's companies that own the base models. Do you think that the same thing will happen to AI foundation models where they will just be ubiquitous and what an AI, the core structure of an AI foundation model will be public knowledge, and then everyone can build it and it's kind of standardized? Or do you kind of see that happening in the AI foundation model, what happened with the internet?
It's already moving in that direction, right? You have Facebook releasing Llama, you have the open source community, DeepSeek, people are developing different models. So it's already moving in a direction of the money to be made in the potential future is going to be more on the application side rather than on the model side, since the models are becoming more a commodity like the internet, as you mentioned. So I think that it is moving in that direction, and you'll see a lot more of that. Every company models themselves will become more commodities, but the way in which the companies tune the models for their specific applications is kind of what you were talking earlier about the application layer, in which if you were to deploy a custom GPT or a specific video model or a specific image model, that might be tuned on what your company has as proprietary that is on top of the layer data.
What are you most excited about AI and drug discovery, in AI and generative models for large data and ambient intelligence? And what are some risks you see in those three categories?
I think it's super interesting to have the opportunity to mine a lot more data now. So if we're looking from a pure research perspective, because of the ability for us to have lower costs on compute and the ability for us to dissect larger amounts of data, there's still a very large foray of opportunity that we have not fully dissected that could lead us to identify new modalities for treating diseases or different interventions that we have yet to discover. So that's on the research side. I think that there's an opportunity there yeah, for research scientists. Now, if research scientists find some crazy version of COVID that we should probably not have be known as a variant or releasing that data into the Ethernet, that might make sense for some more safeguarding or safe or guardrailing around certain AI tooling to not have that be as an output. And that's where a lot of the folks in the trust and safety teams and a lot of folks who are doing preparedness work are tying in their efforts in that space and are culminating this idea of how do we ensure reliable and useful AI, but also taking into account that we want to prevent bad actors from doing bad. The general consensus, even with the work we've studied on risk mitigation, is that if a bad actor wants to do bad, they will still do bad. You cannot stop them. What you can do is you can make it harder for them to do that bad, for example. So you can make it harder for people to get a scalable product out that is going to scale to infect a bunch of people. For example, perhaps it's harder for them to develop a biologic that is something that can be sequenced in a large scale facility. Uh, and for research scientists, it is important to kind of think about, if you are to publish some data, if you are to think about the risks associated with the work that you're doing, how does that fit into the narrative to make sure that you're developing AI that is safe, that is not going to harm people, but also moves the needle forward in discovery. I'm more bullish on AI tooling as a mode for novel discovery, and I think that there's many more opportunities that we have yet to tap into. Protein sequencing, for example, as a means to identify new modalities. Perhaps there's more personalized therapeutics as a means to develop something for you as an individual that will work for your body. It's been research recently shown that even if you and I, for example, eat a bag of chips, my body will react different to those chips than your body will react different to those chips. What does that mean for us if we are trying to create therapies for drugs? If my body is reacting to chips by not spiking my glucose and your body spikes the glucose, should you have a different type of therapeutic built for you that would allow for your body to be more receptive to that therapeutic, whereas for me, it wouldn't really make a difference, right? That I think is super exciting. That is something that you don't necessarily get to see as a as an opportunity if you don't have the ability to mine a bunch more data in an efficient way to get novel insights. So I as going back to what I was saying earlier, was still way too early to kind of decide and say what's happening on the AI front that we should completely not all do anything and mitigate risk. There's certain things we need to protect against, but also understanding that we have many more discoveries that have yet to happen. And so it's the balance of educating the researchers with the same time allowing for the researchers to do their jobs by being able to develop and deploy these AI tools.
Do you, and I'll ask a very broad question, and then it does lead to a more specific question, but I'd like you to answer the broad question first. Do you think the universe is more probabilistic, more based on correlation, such as kind of more the quantum mechanics theory of the universe? Or do you think it is more deterministic, more causative?
I don't know. I mean, that is a good question. Um, I haven't really thought about that too much, to be honest. I think there's so many mysteries of the universe that we don't know, and it's our all of the mysteries of the universe are tied to the best hypothesis of what's happening in the world, or how we think certain things operate. But the more we study, the more we realize that some of our hypotheses might not make sense. So, not sure. It's a good question, but I don't know if I have a good answer for you.
So when we think about, and I have a very strong inherent bias here, which will come across in my questioning. When we think about medicine and AI regulation, specifically within healthcare and the FDA, we seem to be stuck on this concept of explainability or causation. We must understand why this happens. And if AI, say, comes up with a new molecule that we cannot even detect, right? It says there's a molecule that exists, or there's a substance that exists in our blood or in our body called, you know, and I'm just making this name, called a genome or something, right? Something we haven't heard of. And this is what predicts cancer across the board. And AI says, I have this much correlation data, millions of data points. This is what you should look out for. What I need is a picture of you to detect it. That's all I need. I don't need a blood sample. I don't need anything, or I need your voice, something we don't use as a diagnostic. So I'm kind of getting deeper into the woods here. But the question is, are we doing humanity and AI a disservice by being stuck on causation and explainability? And I'm kind of equating the two and determinism versus just recognizing, all we can find out is correlation. Um, and maybe it's because we're not smart enough. Maybe it's because we are limited by five senses. Um, and but we just can't. Like it's an exercise in futility, and we're just wasting time being stuck on explainability and causation. We should just focus on correlation. What are your thoughts there?
Well, like, so you bring up two topics that I will touch base on. What is stuff that we talk about in our classes that we teach on Intro to AI. And there's an aspect of, does correlation imply causation and vice versa? If I were to say that, for example, it's says dry and hot and sunny and it's summer weather, causation could mean that I want ice cream, or causation could mean that I get a sunburn. But does getting a sunburn and getting ice cream, is that a correlation? Meaning that if if I get a sunburn, then I also get ice cream. But does that necessarily correlate to it being dry, hot, and sunny weather, for example? And there's many more different types of, for example, if you have germs, a cause of that could be that it can lead to bad smells, or a cause can be that it leads to diseases. But does bad smell correlate to disease? Not always. And so it's kind of this interesting foray of causation versus correlation. that we bring up in our class all the time when people try to link the two. Uh, I think that for what you touched upon on explainable AI, it's important for us to understand how the AI is making certain decisions such that we can kind of evaluate to make sure it's not hallucinating. So for folks, when I hear explainable AI, for me, that means that I want to understand how it's making its decisions so that I can evaluate against my knowledge base to determine if that makes sense. If I'm saying I'm going to trust a black box, there's been plenty of documented cases now in which the black box does not make a good decision, or it makes a decision that is disadvantageous to certain individuals or certain populations of individuals who might not have their data represented in the data set that the AI is trained on. And so because of that, it creates an output, but that output is perhaps going to impact them in a negative way. And so for me to have an explainable AI, it allows for me to understand, hey, I get how you made your decision. I think this makes sense. I trust your output. Or I see how you made a decision. I see where the faults are. These are the faults we should address. This way, you have AI that's more fair at the end of the day and has a lot more uh, equitable opportunity for everyone and not just one demographic or another. So that's how I view that. But I do think that if AI enables novel discovery, that's a great thing. If it can say that if by this molecule, like you mentioned earlier, by this molecule, you can have this output and all I need is a picture. Well, hey, if I run a study in which I identify that molecule in a bunch of people and all I need is their picture and I throw that into a system and it's 99% accurate, well, maybe that's a new way for doing standard of care. So it goes back full circle to saying, hey, AI can be an enabler and allow for you to be superhuman by doing your job better. But also, having it be explainable is super important because if you don't understand how it's making decisions, how much reliance are we putting on the system, right? And in low use case scenarios like scribing, that you mentioned earlier, that's pretty self-explanatory. Audio in, text out. If it can listen, create correct transcription, it can create a relatively good output. You understand how that system works. Now, for more complicated systems that impact people in their livelihoods, I would hope to understand how it works. Otherwise, I can just be following a black box and directions, and then whoever programmed that black box and or if the AI has been programmed in a way that is detrimental to individuals, right? So that's how I view it. It's an interesting topic, but often the idea of causation versus correlation does come up in terms of does one correlate to another. And for now, there's this balance of actually understanding how AI works such that it's not hallucinating, creating stuff up that's not completely irrelevant to what you're trying to do.
Last question, Artem. Say tomorrow's a hot sunny day, you're having your ice cream, not getting a sunburn, and you run into your 20-year-old self tomorrow. And your 20-year-old self asks you, what advice do you have for me? What would you tell him?
Great question. The thing that, and I get that a lot, um, there's two ways to look at that lens. There's one lens is I am where I am today because of the decisions and the things that happened to get me to the point in where I am today. So then if I am happy with where I am today, would I have changed any chain of actions that happened to get to where I am? That's that first step is I'm
The
great
caveat
today.
being the world is very different today. So if you do the same steps you did in the past 20 years, in the next 20 years, you probably won't get to where you are today. So you probably have to change some things to get to where you are today,
Yeah,
20 years from
but
now.
true. But also it's kind of like this idea of the guided path on which you were on. If that, so if we're saying that if I met my 20-year-old self in 2025 and I told my 20-year-old self, these are the lessons that I've learned, and then these are the mistakes you should avoid from 2025 onward, that would be like a different framing. If I'm thinking about if I were to go back in time and restart and redo things, I would not change anything because everything that has happened has taught me certain lessons that have helped me get to where I am today. Now, if I'm saying, if the question that you're asking is, in 2025, your 20-year-old self is kickstarting their career, is that the question? Kind of like,
Yeah.
okay, so in 2025, if you are kickstarting your career and learning, jumping in, first I would tell my 20-year-old self to pick up CS, so learn how systems work. You don't have to be a professional coder, proficient, but you should understand, you should generally understand how computer systems operate, more so now than before, how large language models operate, what is chain of thought, what is reasoning, what's persuasion. I would encourage myself to read more books on social science and psychology because understanding how the mind works will help you understand how future computer systems will work. First, that's inherent. And I would encourage myself to diversify my experiences in different forays that allow for me to capture a broad scale of exposure and experiences earlier on, and then test those out in different application layers. There's a lot of uncertainty exactly on what will the job market look like in a year from now, 2 years from now, 5 years from now. What is safe? What is not safe? It's hard to tell because today it's safe, tomorrow it's not safe. Today it's changing, tomorrow they're reverting back. Policies are changing all the time. What is safe is identifying something that you are really good at by bringing certain types of skills to the table. And whatever those skills are that you're just good at, you bring those and you sell those skills. Your skills are more valuable than you can always learn how to vibe code. You can always learn new tools that are being developed, but how are you applying your skills with those new tools in a demographic? And so, yeah, for my that's what I would tell my 20-year-old self as a starting point. But if we were to reflect back from 20 years ago till now, I would not have changed anything.
Awesome. Thanks so much for joining me today.
Yeah, no, this was fun. I hope that your audience has a kick and they take an AI class or two. We teach them regularly at Stanford, so they can take a class with me or Ranjan and kind of learn about these systems and or reach out to me directly if they have any questions.